All right, let's just get right into it. We all kind of slog through geometry class, right? But what if I told you that the real stuff, the parts that actually matter, with money, safety, and huge decisions, what if they just left all that out? Today, we're going to pull back the curtain on the geometry you should have been taught.
And right here, this is the big secret. This is the truth they just don't hammer home in school. See, geometry, it's not an art class. It's not about drawing a perfect circle. It's actually a lot more like a courtroom. It's about building an airtight case, defending your argument, and proving something is true, like absolutely 100% true.
So you're probably thinking, wait, if it's about logic, why did I spend a year just drawing stuff? And yeah, exactly. Most of us were just memorizing formulas, right? And the teacher would say, yeah, that looks about right. But that looks about right attitude, that's the whole problem. That's why we miss the power of geometry. And honestly, it's why things can go really, really wrong out in the real world.
Okay, so first up, let's just tear down the biggest lie we're all told about geometry, the one that makes us think it's just some useless school subject.
This right here, this is the huge mental shift you have to make. In school, it's all about, well, it looks equal, so I guess it is. You're just a passive observer. But in the real world, no way. You have to become a lawyer for shapes. Nothing is true until you prove it. You need evidence, your theorems, your axioms, to make your case. Every single claim, every angle, every length, you better be able to back it up with cold, hard geometric law.
So, once you start thinking like a lawyer for shapes, you start to see how that logical framework literally builds the world around us. This isn't just theory on a chalkboard. These are the non-negotiable laws of structure.
And the king of that world, the holy grail of engineering, it's the triangle. I mean, think about it. This is why you see them everywhere. Bridges, cranes, the roof over your head. Try this. Take a rectangle made of, say, cardboard strips. You can easily push it over into a wobbly parallelogram, but a triangle? You can't. It's rigid. It will literally snap before it changes shape. And that right there is its superpower.
Okay, so let's put this into a real-world decision. You're designing a house in a place with heavy snow. An architect might want this really sleek, shallow roof angle because, it looks cool. But geometry doesn't care about cool. The laws of triangles say that as that angle gets shallower, the tension force pulling the walls of the house apart goes up, and not just a little, but exponentially. So the engineer has to step in and use trigonometry to prove that this beautiful design won't literally rip the house apart under the weight of the first big snow.
And it's not just about things collapsing. This same kind of logical proof applies to decisions with huge financial stakes. I'm talking about situations where one tiny geometric mistake could cost you a fortune.
All right, put yourself in this situation. You're about to buy a piece of land. It's an irregular shape, not a nice, clean rectangle. The seller hands you the measurements for the sides and says, yeah, just multiply the length and width. It's pretty much a rectangle. So, do you trust them?
The answer is no. You absolutely do not. Because you can't assume a 90-degree angle when money is on the line. The smart move? You take one extra measurement, the diagonal. Boom. Now you've split that weird shape into two simple triangles. And there's this amazing tool called Heron's formula that lets you find the exact area using only the lengths of the sides. And look at this. The difference between the seller's good enough guess and the geometric truth? Over $12,000. That's a pretty expensive assumption.
All right, let's switch gears to a problem we all face: Wi-Fi. You've got an L-shaped office or maybe just a weird room in your house. The easiest thing is just to shove the router in a corner, right? Out of sight, out of mind. But is that the smart geometric move? See, a Wi-Fi router broadcasts its signal in a circle, a 360-degree radius. When you stick it in a 90-degree corner, you are literally wasting 270 degrees of that signal. That's 75% of your Wi-Fi power getting blasted straight into the walls where it does absolutely nothing. It's kind of crazy when you think about it. You need a router 4 times as powerful in that corner just to get the same useful signal as one placed in the middle. And here's the kicker. You can't just buy a booster to fix bad geometry. It just doesn't work that way.
Okay, so we've covered money. We've covered convenience. But now, let's talk about when geometry gets really serious. When a simple misunderstanding isn't just costly or annoying, but actually dangerous.
You probably remember this word from your textbook: tangent. It sounds so academic, right? Just a straight line that touches a curve at one single point. Seems pretty harmless.
While that simple little line can create a lethal blind spot.
Here's how it works. Imagine you own a house on a street corner. A driver pulling up to that corner needs a clear line of sight to see oncoming traffic. That line of sight is a tangent line to the curve of the road. Now, the area between the road and that tangent line forms what's called a sight triangle. And if you decide to plant a big, beautiful hedge or put up a fence inside that triangle, you've just created a dangerous blind spot. And here's the scary part. If an accident happens because of that blind spot you created, you, the homeowner, can be held legally responsible.
Okay, let's bring it back inside the house for a minute, with a mistake that is just so incredibly frustrating. You've just designed your dream kitchen. You've spent a ton of money. Everything is installed, it looks amazing, and then you go to open the dishwasher for the first time. And bam, it hits the drawer handle next to it. You can't open it all the way. Professionals have a name for preventing this. It's a concept from the geometry of motion. They map out the locus, which is just a fancy word for the path, of every single moving part. So they map the path of the dishwasher door swinging open, and they map the path of the drawer pulling out. And they check, do those paths intersect? If they do, they're going to collide. It's called clash detection, and doing this simple geometric check is what saves you from one of the most maddening design flaws you can imagine. All right. This all leads us to the final and maybe the most important piece of the puzzle. It's the big secret about the difference between the perfect, ideal geometry we learned in school and the messy reality of the world we actually build.
In a textbook, a line is perfectly straight. It has no width, no imperfections. But in an engineering workshop, a straight line has something called a tolerance, an allowable amount of wiggle room, maybe a few thousandths of a millimeter. Think about a huge steel bridge. It's designed with precise geometry, sure, but the engineers also have to calculate how much that steel will expand in the summer heat, changing its geometry. That's why they build in expansion joints. Without them, the bridge would literally tear itself apart.
And that, right there, is the biggest takeaway. School teaches us the ideal, the perfect version of things. But the real world is built on managing allowable imperfection. The whole point of learning about perfect shapes isn't just to know about them. It's so we have a benchmark, a starting point to understand and control the messy real world. That's what real engineering is. It's the art of managing imperfection.
So, I want you to think about this. The next time you see a skyscraper that's literally designed to sway in the wind, or a bridge that has those visible gaps in the road, remember, that's not a mistake. That's not a flaw. It's a feature. It's geometry at its absolute best, designing things not to be perfect, but to be resilient in an imperfect world. So my question to you is, what perfect geometry that you see every day is actually designed to flex, to bend, and even to safely fail?